Hello, everyone, and welcome to Rational Expressions and Equations lesson number 2. So we are just going to continue on with simplifying these expressions. And in part 2, we're just looking at more complex examples. So I'm not going to do all of them. I'll try to hit all the ones that I'll try to do enough that I cover everything. But we'll start with the first 3 here, and then we'll go from there. So if we're looking at A, we have 4t to the power of 3 minus 9t, all divided by 2t squared minus 3t. So we want to start just simplifying a little bit. So the top, we can pull a t out of the top so that we've got 4t squared minus 9t. And then the bottom, we can pull a t out as well. So now we have 2t minus 3. Now that we're here and we've got the denominator split up into factors, we can state our non-permissible values. So we can say t cannot equal, well, we can't have 0. And in this case right here, if you remember solving quadratic equations, if you're trying to find the value of t that's going to make that factor 0, you can take that and equate it to 0 and then solve for t. So you would add 3 to both sides. You get 2t is equal to 3, divide by 2, divide by 2. T is equal to 3 over 2. So that's one of the non-permissible values. What you can do as well is if you have a binomial with a constant, let's just make one up, 3t plus 4. The t value that will make that 0 is going to be a fraction where the top number is the constant, and then we change the sign. So it's a positive 4, we change it to negative, and the bottom number is the coefficient in front of the t. So that one would be negative 4 over 3. If you had 2t minus 1, well, the value that makes that factor 0 is going to be positive 1 in the top and 2 in the bottom. Just a quick a shortcut way so that you don't have to do that little bit of algebra every time. I'm going to erase that just to get it out of the way. Okay, so we've got it. We've got our non-permissible values done. So now we can simplify this. Right away, I know that t over t cancels, so I'm just going to get rid of that. And then in the top, I have 4t squared minus 9. Oh, I'm supposed to have minus 9, not 9t. Hopefully someone caught that early and is trying to yell at me through the screen. That's the difference of perfect squares. So we can actually split that into, make sure we put our equal signs here. So on the bottom now we have 2t minus 3. And on the top we have the difference of perfect squares. So 4t squared we can find by doing 2t multiplied by 2t. And 9 is 3 times 3. 1's a plus, 1's a negative. And then you can see that we have a 2t minus 3 in the top and the bottom. So we can cancel those out. And we're left with 2t plus 3. So we have our non-permissible values, and we have our simplified rational expression. All right, let's look at the next one. We have 2x squared plus 5x minus 3, and we have 2x squared plus x minus 1. So we actually have to do decomposition on both the top and the bottom. We can't factor that 2 out to do inspection, so we're going to have 2 decompositions. So let's just look at the top first. 2 multiplied by negative 3 is negative 6. So what that means is I'm going to split my positive 5x term into 2 numbers that multiply to negative 6 and add to positive 5. So we can split that into, what do we got? Negative 1 plus 6, or negative 1 and positive 6. So then I can say 2x squared, and I'm going to split that 5x into negative x plus 6x minus 3. And then on the bottom, I'm going to go 2 multiplied by negative 1 to get negative 2. So I'm going to split my positive x into two numbers that multiply to negative 2 and add to positive x. So maybe positive 2 and negative 1. So I can split that bottom one into 2x squared plus 2x minus x minus 1. And now we can do factoring by grouping. So in the top, I'm going to group my first two and my last two and factor out a common factor. So in the first one, I can pull out an x term, and I'm left with 2x minus 1. And in the second one, I can pull out a 3, so plus 3, and I'm left with 2x minus 1, which is good. We want those binomials to match. And then in the bottom, I can group the first two and the last two. And in the first one, I can factor out a 2x by the looks of it. So let's factor out our 2x, and we're left with x plus 1. And in the second one, it's negative x minus 1. So I'm just going to factor out a negative 1. And that leaves me with x plus 1, which is perfect. I want those binomials to match. So now I can rewrite the top. I can factor out that binomial. So now I have 2x minus 1 and x plus 3. And then in the bottom, I have 2x minus 1, x plus 1. So now that we've got the bottom broken up into two factors, we can write down our non-permissible values. So x cannot equal negative 1 from the second factor. And if we use our little trick, positive 1 over 2. Those are my non-permissible values. And I can simplify this expression now. There's a 2x plus 1 in the top and the bottom. So now I have x plus 3 over x plus 1. And that's as simple as that one goes. All right. That one is one of the longer ones, right? With the decomposition in both top and bottom. But very doable. You all have those skills. So let's do the third one. So we have a squared plus 2a minus 8 in the top. I can deal with that one by inspection. And then in the bottom, I have a to the power of 4 minus 20a squared plus 64. So whenever my polynomials go to the power of 4 to the power of 2 constant, or to the power of 6 to the power of 3 constant, you can factor this like normal, but instead of just putting an a term, they're going to be a squared. So I'll show you what I mean. Let's do the bottom first. So the bottom, if that was just a regular trinomial with an x squared at the front, we would just put, or an a squared, sorry, we would just put a and a. But because it's a to the power of 4, it'll be a squared and a squared. And now we're just looking for two numbers that multiply to 64 and add to negative 20 like we normally do. And I'm just going to go through it quicker. So the two numbers are negative 4 and negative 16. If you need to do your multiplication chart on the side, definitely do that. All right, so let's do the top one now. This one's a basic inspection. Two numbers that multiply to negative 8 and add to positive 2 are going to be negative 2 and positive 4. So you can see here that we don't have these quite reduced to factors. But you notice that this one here, a squared minus 4, is a difference of perfect squares. And this one is also a difference of perfect squares, a squared minus 16. So we can split. So let's rewrite the top, a minus 2, a plus 4. And then in the bottom, we can split the first factor into 2. A squared is a times a, and 4 is 2 times 2. 1's a plus, 1's a negative. And then the second factor, a squared minus 16, can be split into 2 factors. A squared is a times a, and 16 is 4 times 4. 1's a positive, 1's a negative. So we haven't done non-permissible values yet, but we haven't done any canceling out. We haven't done any simplifying. We've just split these into factors, so that's totally okay. Now that we're here, we can say, okay, well, our a values cannot equal plus or minus 2 and plus or minus 4. Those are the non-permissible values. And now we can do some canceling. So there's a minus 2 here, and an a minus 2, and an a plus 4, and an a plus 4. So that leaves us in our rational expression with 1 over a plus 2, a minus 4. And we're done. Awesome. Now let's go on to the next set of problems. I'm going to do the first one, and I'm going to do the last one, but I'm not going to do the middle one. So you can see here, we have c minus 4 divided by 4 minus c. So right away, let's look at the bottom, 4 minus c. Let's state a non-permissible value for this because it isn't in, it's in a factored form. So 4 minus what is going to make that 0? And obviously that's 4. So c cannot be 4. That's our non-permissible value. And hopefully you recognize that, these aren't exactly the same, but we can do a little bit of tinkering to make them the same. So if you factor a negative 1 out of the bottom, so the top stays the same, c minus 4. But if you factor a negative 1 out of the bottom, it's going to change the signs of both of the terms inside the brackets. So that becomes negative 4 plus c. And then you can actually rearrange that, right? C minus 4 on the top, negative 1, because we have negative 4 plus c, and you can rearrange it as c minus 4, or positive c minus 4. And when you do that, you notice that they cancel. You're left with 1 over negative 1, which is just negative 1. So you are allowed to change the order of the fractions, and sometimes you have to do that by factoring out that negative 1. All right, let's look at C. C is a little bit more complicated. I think that's going to be the last one that I do. Actually, I'll do one more on the next page. So the top, you notice 1 minus 4x squared is a difference of perfect squares. 1's a perfect square, 4x squared is a perfect square, and it's a difference, it's subtractive. At the bottom, 6x squared minus 5x minus 4 is a trinomial with a constant in front of the x squared term. Can't factor it out, so we have to do decomposition. So let's first do the top. So the top can be factored according to difference of perfect squares. 1 is a perfect square because 1 times 1 equals 1. And 4x squared is a perfect square because 2x times 2x equals 1. 1's an addition, 1's a subtraction. The bottom, we have to do decomposition. So we're going to go 6 multiplied by negative 4, and that's going to get us negative 24. And we're looking for two numbers that multiply to negative 24 and add to negative 5. So I think if you go negative 8 multiplied by positive 3, that multiplies to negative 24 and it adds to negative 5. So I'm just going to rewrite that trinomial, but I'm going to split that middle term, that negative 5x term, into 3x minus 8x minus 4. And I haven't canceled anything out yet, so I don't have to have my non-permissible values written down. You just have to do it before you cancel so that you don't forget about any. I'm going to factor by grouping here. So I'm going to group the first two and the last two and pull out a greatest common factor. So I can pull out a 3x and I'm left with 2x plus 1. And in the second one, I can pull out a negative 4. So I'm left with 2x plus 1. So now I have 1 plus 2x, 1 minus 2x in the top, and then I have 2x plus 1 and 3x minus 4 in the bottom. So now I should do my non-permissible values, because the next step is to start simplifying or start canceling terms. So x cannot equal negative 1 over 2 and positive 4 over 3. And now when I cancel, hopefully some of you recognize that 1 plus 2x and 2x plus 1 are the same value. Because they're both positive, they don't need to be in the same order, right? Because if you have positive 1 plus 2x, that is equal to positive 2x plus 1. The order doesn't matter when it's positive. So we can cancel that out. And we're left with 1 minus 2x in the top and 3x minus 4 in the bottom. Okay. There's a word problem here. We're going to skip through that. I'm not even going to do these last two. I just want to show you this last one here. It's x plus y on the top and x minus y in the bottom. So you can't really simplify anything. No simplification. But now when we go to do our non-permissible values, we have to do it a little bit different. So we have x minus y as our denominator. That can't be 0. So basically all you have to say is x cannot equal y. Right? If x is the same as the value of y, then that bottom is going to be 0. So that's your non-permissible value there. I just wanted to show you that. Actually, you know what? Let's do one more just for fun, because you're going to start seeing this more where the non-permissible values have a y in them as well. So I want to show you another full example. So the top is x plus 5y. Can't simplify that. But the bottom is x squared minus 25y squared. So what we can do here is we can simplify that with difference of perfect squares. So we can change that to x minus 5y and x plus 5y. And now we can say x cannot equal positive or negative 5y. And then we can reduce, and we get 1 is x minus 5y. 1 over x minus 5y. So it's kind of the same idea here as we did over here. Cool. Hopefully that made sense. Practice is going to make everything a lot easier in this unit, so make sure you practice a ton. Thanks for watching. Don't forget to like and subscribe.